First of all, welcome all of you on behalf of Kubernetes Sri Lanka user group. I welcome all of you to this session. So let me share the presentation as well. Okay, right. So hope you guys are seeing the screen. So as Nilesh did the intro, today's session is going to be on cluster API, which is the cluster management API of Kubernetes. So the topic, I've named it as clusters as cattle with cluster API. So we'll like create a flow into the session, sort of like the cloud and the cloud native concepts and what cluster SaaS cattle means and how cluster API lets us do that, right? So yeah, so let's start then. Okay. So first of all, a little bit about me. So my name is Chamila Liyanage. I work as a software architect at LSEG Technology. So LSEG Technology is into building stock exchange systems, trading platforms that powers the stock markets. So before joining LSEG, I worked at PSN, and before that, I worked at Zenit. So it's a kind of a long journey. And also, I'm also doing a YouTube channel called Kupier. So you guys can check that one out as well. It's YouTube/Kupier SL. So in that also we conduct webinars, not in the sort of like conventional, sort of like the formal way, more of it's sort of like typical Kupier would happen. So all sessions are conducted in Sinhala. So you guys are welcome to check that one out as well. Okay, so let's start the session with like creating a background, right? So what is cloud and what is cloud native? So one way of looking at it, right? So a lot of people take this as a sort of like a joke, right? There is no cloud, it's someone else's computer. So although we like think of this as a joke, when you actually talk with some people and how they treat cloud, you kind of tend to think they actually, although we think it's a joke, but in reality, they actually are just treating the cloud as someone else's computer, right? So so in the traditional way, in where we had the data centers, where we had to buy our own infrastructure and manage computers, and now when we are shifting to the cloud world, right? So it's I wouldn't say that like this is 100% wrong, because now you are not managing your infrastructure, right? So now you are not managing your servers. Amazon or Google or Microsoft or someone else is basically managing the servers, and you're using someone else's computer, right? But the wrong way to look at it is, right, so just because that the machines are not yours, right, we shouldn't think of cloud as a destination, right? So a lot of people, when we talk with people, it's like if you had a traditional application that was running on-prem. So you take a project like, let's say, terminology like cloud migration or something like that. You take that software and put it in the cloud. Now it's running on cloud. So that's the wrong mentality of thinking it cloud as a destination, right? So cloud is not a place where you deploy your software. It's a how you build your application and how you deploy your application and how you use the infrastructure. So cloud native is just more than signing up with Amazon or some cloud provider and taking your workload and deploying it in the cloud. So if you take the same application architecture that was built for on-prem or a data center based application and you put it in the cloud, that doesn't make it cloud native. Just because it runs in cloud, that doesn't make it cloud native. So cloud native is not about the where, right? It's about the how you design your applications, how your application is architected, how it's deployed, and how it works on the cloud. So it's a more of a how and not about where or not a destination sort of, right? So it's a way you design your application and making use of the cloud infrastructure. So cloud native is an approach where you build or you architect your application and design your application and makes the full use of the cloud infrastructure, advantages of the cloud computing model. What I mean by that is, like, if you have an application and your application is not designed to benefit of a feature like auto scaling, right, where your state is not externalized and your application maintains some state, you can't actually make the full potential and use the full advantages of the scaling, horizontal scaling models provided by the cloud infrastructure. So in that essence, when you're actually creating application or you're crafting your application, you need to take into consideration and also put some thought into what infrastructure this is running on, and what are the benefits of, or like what are the advantages, or what are the features that's provided in that infrastructure, and design your application to make use of it, right? So the other way, like it goes the other way as well, right? So if you are like deploying your application not on sort of like a SaaS-based way, and you're giving each customer and you take instance for each customer and like deploy their own hardware, then you don't need to actually think about this scaling and like making this as small loosely coupled microservices kind of architecture. So if it's that infrastructure is not supporting that kind of thing, going for that kind of architecture is going to be an overkill. So so it depends on the nature of your application. So you always need to consider when you're designing application, what kind of infrastructure this runs on, and what features that infrastructure offers as well. Then if you move on to one of the analogies that we have in this cloud native thinking is pets versus cattle, right? So let's see what pets are and what are cattle, and what kind of model that we should choose for the cloud native world. So if you take pets, right? Pets are things that you love and you care about, right? So early days when we take a server, you kind of give them very caring or loving names. So I remember like every time I bought a laptop, I used to name it, right? So, make it Rivendell or Isengard or something, right? So a lot of companies also do this, right? You have a email server, you might call it like SpeedMax or Thunderbolt or something like that. And then you call your FTP server Optimus Prime or something like that, right? So you have sort of like these emotional attachments with your physical infrastructure because they are unique things, right? So your email server, you have let's say a documented procedure of how you start the server, then when the logs are filling up, what script to run to clear that. So it's a unique thing, right? So just like the pets that you own, so your pet is like, it's not just a animal or something too, it's a pet, you care about it, right? So if your pet gets sick, you like nurture him and like take care of him and make the same server come back up, right? So you don't get rid of that and create a new one. So that's the pet analogy. So, and in normal, like in a data center based approach, that's what we used to do as well, because we buy our infrastructure beforehand. So we have already paid the bill and we've got the server. So it's up for us to keep running our applications on those servers. So if something goes wrong with that server, all hands on deck, we fix the server, do whatever it takes to fix the server, right? So that is the way of treating your infrastructure or servers as pets. So cattle, on the other hand, it's like you have no emotional attachments with your servers, right? So they get like random names. So, IPs, the dots replaced by, like underscores, or some starting name and then set of like a random numbers or a GUID. Your servers are like no longer unique things, right? So they are created from templates, right? In different infrastructures, you might call them like machine images or machine templates, right? So you have a template, and each time that server goes like it's in a bad state or you don't want it anymore, you just get rid of it and create a new one. So you don't like have this uniqueness like pets anymore. So you start treating them like cattle, right? So if you're in the cloud world, the cloud native way of handling your resources are the cattle mentality, right? So there are no more unique things. So at any given time at will, you are able to spin up a server, and if something goes wrong with that, you just get rid of that and create a new one that's almost identical to the previous one, right? So it's the main difference is like, so if pets are like these unique things which are vitally important, but cattle, you just need one of those servers. It doesn't have to be, you know, X or Y. It, as long as you have one kind of server like that, it's fine. So it's interchangeable, right? So at any given time, you can create one as you wish. So some of the examples for these cattle kind of servers are, if you take nodes that are within a auto scaling group, auto scale nodes, you just care about like how many instances needs to run at a given time. You don't care like, is it the same server that I first created? Is it like something that the auto scale group created? So when the load is increasing, there'll be more nodes. When the load is decreasing, there'll be less nodes. So you don't really know like, is it the same server that I first started? And you don't care about that as well. So as long as that there's like given sufficient number of instances running, that's all you care about, right? So same goes to the Kubernetes pods as well. You just define a way, or you define the spec of the pod. I want this container to run, and I want this number of instances to run. So it doesn't have to be like the first time you created that one needs to keep running. There's nothing like that. So if an application crashes, Kubernetes just gets rid of that and creates a new one, right? So it's, you basically care about the configuration or the specification, and you don't really have to know like, is it the same thing or a different thing. It will be, if it doesn't work, a new one will be running for you. That's all you care, right? So you no longer have like this uniqueness within those resources. So every resource in the cloud native world needs to be thought of in that way. It needs to be treated like cattle and not like pets, right? So what is Cluster API, right? So Cluster API is a Kubernetes API or a project that aims to build that cattle-like nature to Kubernetes clusters themselves, right? So right now, if you take Kubernetes cluster, all the resources within a Kubernetes cluster is treated like cattle. Resources within Kubernetes are treated like cattle. So that means if something goes wrong, Kubernetes like brings another one up, right? And you always give that specification as a declaration through YML or some other format. You give your desired state. This is how I want my application to run like. So if that is not the actual state, Kubernetes reconciles that, and it creates like the state that you are supposed to run your application. So it's, the resources are treated like cattle. But if you take the Kubernetes clusters themselves, sometimes those are like not managed like cattle. So that means you are having like a you take your clusters as like, oh, I have a cluster, I start from there, and you don't really treat your Kubernetes clusters as cattle, right? And the cluster API is something that tries to address that concern and lets them treat your clusters as cattle as well. So that means in the morning, if you need a Kubernetes cluster, you spin up a cluster. When you're going back, you just shut down, and next day you create another one, right? So the other thing to note is like, although Kubernetes like inbuilt doesn't have this capability, a lot of cloud providers and other providers like lets you have this functionality. So if you take right now, you might ask me, why do you need a cluster API, right? I can go to AWS, I can go to EKS and say, create a cluster, just click a button, you have that. You go to GCP, you get GKE, click a button and you get a cluster. Same with Azure, you got AKS or something like that, that creates a cluster for you, right? So that facility is sort of there, but the problem with that is like each of the cloud providers uses their own way of provisioning clusters. So to provision a cluster, Kubernetes cluster in AWS, you might need AWS CLI and some different specifications. For Google, you might need the G Cloud terminal, and there's some different commands. So yeah, there's no central conformance of creating clusters across different vendors. So Cluster API tries to address that as well, right? To manage lifecycle of Kubernetes conformant clusters. And also it tries to like give a similar API. So you define your cluster in a similar way, and you can use the same specification, well, almost same specification across different cloud providers and in on-prem managed clusters as well. So that means like if you have VMware, vSphere or something like running on your on-prem infrastructure, you can use like the almost same scripts or like the same specification to provision your clusters in on-prem and the cloud as well. So we know that this is true for Kubernetes because if you have your application manifest written in YAML format, you can use kubectl apply and apply to a like an on-prem cluster or a like AWS or GK cluster in the same way. So Cluster API tries to bring that goodness to Kubernetes cluster creation as well, right? So we'll see how that is done in the coming slides. So this is like the official sort of like the definition of Cluster API, right? So the Cluster API is a Kubernetes project to bring declarative, right? So this is very important. So we know in Kubernetes everything that we say is declarative. So that means we like write a specification. This is how I want my cluster to look like. This is the name of the cluster. I want 3 control plane nodes and I want 5 worker nodes, like that. It's declarative. And a Kubernetes style APIs, right? So it's an API driven thing. So you can basically use the Kubernetes API to tell how I want my cluster to look like this and use the API, right? So and it manages Kubernetes style API to create clusters, configure and manage, right? So basically this is the whole life cycle of the cluster, right? Cluster creation, configuration and management. And also what Cluster API does is it doesn't it doesn't reinvent the wheel, right? We know that this declarative nature and the reconciliation loop is already available in Kubernetes. So what Cluster API does is it just adds some additive functionality through custom resource definitions on top of core Kubernetes, right? So it provides optional additive functionality on top of core Kubernetes, right? So this last statement is sort of like you might think of it like as a chicken and egg situation, right? It says Kubernetes to manage lifecycle of Kubernetes cluster, right? So we are trying to use Kubernetes itself to manage the Kubernetes cluster, right? So that's interesting analogy, right? We're using Kubernetes itself to manage Kubernetes clusters, right? So let's see what that's all about and how that is done in the next slide, right? So this is like a high-level overview of the Cluster API, right? So you as a user, you define your cluster state or the cluster manifest, right? So just like you would say how you would create a Kubernetes deployment, you would create a new object called cluster, right? We give the cluster a name, what kind of machines to use, right? Whether it's small or large, those kind of things, and then how many control planes you need, and the machine deployment is like what templates of machines you want to use to create the cluster. So we'll get into the actual YAML definition in a bit, but the important thing or the thing to grab here is that you no longer like does it in an imperative way. You define the cluster specification, right? So you have a cluster specification in YML format. How do you want my clusters to be created, right? So this is what allows you to like create clusters at will, because you have a definition. Now you can just reuse that to create multitudes of clusters. And then you give that specification to a Kubernetes cluster. We call this special cluster a management cluster. So it's a cluster that runs Kubernetes, and it also runs cluster API. So you basically take this specification and give that to cluster API. And then cluster API is capable to provision clusters across different infrastructure providers. It could be in AWS, it could be in like VMware vSphere, Google Cloud, or Microsoft Cloud as well, Azure Cloud as well, right? So you can use almost the same specification, the cluster definition, and use that across different cloud providers, right? So you use the management cluster to provision your Kubernetes clusters across different vendors or different infrastructure providers, right? So that facility is something that's much needed by sort of like large organizations where they have some of their workloads, let's say the testing and the dev environments in a local infrastructure provider like VMware or something, and then they have their production workloads in a cloud provider like AWS or Google, and they might also have some clusters maybe for experimental or ongoing evaluations. They might also need to have the same thing on a different vendor as well. So managing all of your Kubernetes clusters in a similar way, it's something that's like much needed and asked by a lot of people. And cluster API is not the only way, but it's one way that's being done, and it's an open source project that tries to address that capability. Okay, so at the if you like to see how this is implemented, right? So it's not a tricky implementation, it's an easy implementation, right? So since we know Kubernetes, it will be easy for us to understand how cluster API works as well, right? So cluster API is nothing but a set of CRTs or custom resource definitions. So custom resource definitions are the way of extending Kubernetes. So if you want to add like additional or additive functionality on top of Kubernetes, that's a standard way that Kubernetes lets you do that. So it uses set of custom resources, and it uses some custom controllers, 3 custom controllers to implement these CRTs. So think of CRT as like before you had in Kubernetes, you have objects like pods, deployments, replica sets. Now through the custom resource definitions, you are able to create object called cluster and a machine deployment like that, right? So for those resource or the custom resources to be implemented or some actions to be performed on top of that, you need some actual functional running code. So those are what's included in these clusters. So at very high level, it's basically set of controllers and a set of custom resource definitions. That's the implementation of cluster API. That's how it's implemented. So these are like the main custom resources. So the color codes here actually represent like which custom resource is handled by which controller. So if it's like light blue, it's handled by the cluster API controller. If it's like this yellowish kind of thing, it's handled by the Bootstrap provider controller. And if it's like this greenish thing, it's handled by the infrastructure provider controller, right? So you define a cluster. You say, okay, I want dev cluster 1 or dev cluster for team 1, like that. So all the generic things which are not infrastructure specific, you specify in these generic things. Everything in blue are the generic things, right? So cluster is a generic term. Then there's like you think of this cluster as a think of it as like the superclass, and this is like a inherited or a subclass of that. So everything that's infrastructure specific, you put it in this resource definition. You have the cluster and the infrastructure cluster. So the infrastructure cluster could hold things like in which region you want this cluster to be created, because region might be a thing that's specific to a particular vendor, right? So in AWS, you might have it as region. In Google Cloud, you might call it something else, right? So that is what that sort of like separation is created through this the generic definition and the specialization or the infrastructure like sort of like the overriding of that. Then think of machine and machine deployment as sort of like, think of this as like a deployment in Kubernetes, and think of machine set as a replica set, and think of machine as like a pod, right? So you have a machine deployment where you say, I want a fleet of machines to run, right? For example, it could be 3 control plane nodes and 5 worker nodes. So machine deployment is the thing that you use for that. And the bootstrap config, right? So we'll get into this a little bit detail, but Cluster API allows you to choose your bootstrapper for you as well. So bootstrapping is like how you create your Kubernetes cluster. So you basically like have physical nodes, and now you want to turn that to a Kubernetes node, right? So you want your physical or virtual machine to run Kubernetes, right? So there are different bootstrappers available like kubeadm, kops, or kubespray, and Trust API defines it as an API, and then you can like have your favorite bootstrapper use. So right now, since it's a V1 Alpha 3 state, as I know, it's only right now the implementation is for kubeadm, but they have that provision. So let's say in a later stage you want to use kops or kubespray or some other bootstrapper provider, that facility is available. So you basically have to swap out the kubeadm bootstrapper provider with your kops or kubespray or whatever your bootstrapper provider. So that design is thought of, and that separation of concern is already in Cluster API. So you just basically needs the implementation for different bootstrapper providers. So in the machine deployment and machines, you have the bootstrap config. So, if it's kubeadm, what kind of extra args do you need to pass to the controller manager or the kube API server? Those kind of bootstrap level configurations are allowed to be used here. So that config will be implemented or used by the bootstrapper provider, right? So that these things also could be different. If you're using a different bootstrapper, the settings might be different. And then infrastructure provider, as you could guess, takes care of provisioning like the VPCs or the computing instances, right? It could be EC2 instances or compute instances or whatever your infrastructure calls them. Provision the load balancers, the computers, the networking rules, and all of that is taken care of by this infrastructure provider. So in any cluster, you can have multiples of these as well, because let's say you want to provision clusters in AWS as well as GCP, then you can have multiple infrastructure providers running as well. So it basically creates the infrastructure for you. So these are some of the key concepts in Cluster API. So we have the management cluster. So management cluster is this. So you tell all your cluster definitions to the management cluster. So that is like the index or like the registry of all the clusters. So everything that you tell Cluster API is held in the management cluster, right? So Kubernetes cluster that manages the lifecycle of workload clusters. So workload clusters are the ones that the actual clusters that we are using. So all the manifest or the registry is maintained in this cluster called the management cluster. So both of these management and the workload clusters are Kubernetes clusters itself, right? So workload cluster is the actual cluster that we are going to use, right? So these workload clusters are managed by the management cluster. So in here, you can see this is the management clusters, and these could be different workload clusters. So within AWS also, there could be like another arrow like this, where these are the actual clusters that we use, right? So those are called workload clusters. So infrastructure provider is something that we discussed. So the provisioner, or like who takes care of provisioning infrastructure for you, right? So the infrastructure providers include AWS, Azure, Google, and even VMware, vSphere, and others. So this list will obviously grow as well. So for each infrastructure provider, it will be a different controller. So that's the only difference that will happen in the management cluster. So Bootstrap provider, again, generating the cluster configuration, initializing the control plane, and joining the worker nodes and the master node to the cluster. So that is like basically the bootstrapping process, or like how you like use an existing node and turn that into a Kubernetes node, part of Kubernetes. So that's the Bootstrap provider's job. So as we discussed, like Cluster API does not dictate you to say, oh, you have to use this Bootstrapper provider. You can swap out, like in future releases, I think they'll introduce other Bootstrapper providers as well. For right now, and for this demo, we'll be using KubeADM as the bootstrapping provider. So that is like it for the theory part. So hope that kind of gives a like a overview of what Cluster API tries to do, and also some knowledge to you of like how Cluster API is actually implemented and how it is functioning. So let's sort of get into a demo. So this is like the demo setup we are going to use today. So user, that's me, right? So I have my laptop set up and I have kubectl, and obviously for Cluster API to run, we need a management cluster. So today I'm going to use Kind as my management cluster. So you can basically use any Kubernetes cluster for that purpose. It could be Minikube or something. So I'm just going to use Kind today. So Kind, for those of who don't know what Kind is like a even tinier version of Minikube, right? It's basically a Docker container that has Kubernetes inside of it. So for this kind of demo purposes, it sort of works, right? And we are going to use that management cluster, and we are going to actually provision a cluster in the AWS infrastructure. So you can use the same things in, I will show the documentation for those as well, but you can virtually use that for different cloud providers as well, like GCP or Microsoft Cloud and like that. So sort of like I keep a high level snapshot of this, so it will be clear when we are going through the demo, right? So let's get into that. First, let's share the terminal. Yeah, you guys can see the screen now, right? The terminal. Yes.
Yeah.
Okay, cool, awesome. Right. So everything I'm doing, right, it's no black magic or things like that. So I'm gonna straight off use the documentation, right? So if someone wants to follow along and you want to try that in your own time, there's nothing magic, right? It's straight off the documentation. There's no special things that I'm going to do, right? So if you already have a cluster, that's good. If you don't, you can use Kind or Minikube or whatever you prefer to create a cluster, right? So I have created a cluster right now. It doesn't have anything, right? It just has the main namespaces, right? So now what we are going to do is, right, turn that existing Kubernetes cluster. Here I'm using the Kind cluster, and I'm going to turn that into a management cluster, right? So in order to do that, right, with V1 Alpha 3, they have introduced this command line utility called the clusterctl, right? I mean, like another command line utility, right? Not so great, but it kind of like makes things a bit easy. But essentially, if you don't want to use this, still it's okay. So basically what this does is it basically does 3 kubectl creates for you, right? So you install the cluster API definitions like this. Then it installs a Bootstrapper implementation, and then it installs an infrastructure provider like this, right? So if you don't want to use the cluster CTL command line utility, you're free to use this approach as well, but using this is kind of easy, right? So these steps are all about downloading and setting up the cluster CTL utility. So that's optional, right? So and then for each of the infrastructure providers, so if you remember, you have the cluster API controller, the Bootstrapper controller, and the infrastructure provider controller. So what infrastructure provider you are going to use, or if you want to use multiple, you have to say that. And the configuration for each of the infrastructure providers are kind of different, right? It's basically depends on how the cloud APIs are exposed by different vendors. So here we are going to use the AWS, but for others also there's this documentations, right? So AWS credentials and the CloudFormation stack, all the steps are there. So what I'm going to do is now I'm going to use this cluster API or the cluster API command line utility to initialize a cluster, and I'm going to use the infrastructure provider AWS, right? So if you want something else, you can use it like this, right? So right now it only has these namespaces. So let's try this. It'll it's gonna take a little time for it to download the images for the different controllers and run, right? So it's basically, you should see these steps happening, right? So it's going to fetch the providers, right? So providers are basically what infrastructure provider you're going to use, and then it's going to install the cluster API components in the CAPI namespace. And then since we are going to use the bootstrap of KubeADM, it's going to use the bootstrapper provider of KubeADM, and the control plane that's also going to be of KubeADM, and the infrastructure provider as AWS, which will be in the Kappa system namespace, right? So if you don't want to do this, you can run these three commands as well, right? So basically the cluster API components, the bootstrapper components, and the infrastructure components. So yeah, so that's the thing. So we are gonna experience this kind of slowness when we're actually creating the actual cluster as well. It takes a bit of time, but shouldn't take too long. Okay, we'll have to wait till that step is complete to.
So for adding worker nodes to the cluster kind, so do we have any separate kind for adding nodes to that cluster through cluster API?
Yeah, so you mean the different worker nodes and the control plane nodes, right?
Yeah.
Yeah, so I'll show it to you. So we have a YAML definition like this, right? So we still didn't get to that part. So this is the definition to create the cluster, what kind of machines to use, and how many machines we want to use. All that is we can tell that declaratively. So once this is set up, we'll get to that. Okay.
Okay, sure.
Yeah. So now if you see, there's these additional namespaces created, the Kappa system, the CAPI system, right? So this is the cluster API components. This is the cluster API. This is the cluster API components. This is the cluster API for AWS, and this is the Bootstrapper component namespaces, right? So that is done. Now what we can do is we can now actually create our first workload cluster, right? So now my management cluster, if I something like this, right? So there are no clusters created, right? But it didn't say it doesn't know clusters because it's like we installed the custom resource definitions. Now it knows object called clusters exist, but right now there's nothing like that, right? So the next step is we are going to create a workload cluster. This is like our actual cluster creation, right? So here, if you want, you can use like this template, right? So it's like for each cloud provider, if you specify some environment variables, and if you run this command, it will sort of like generate a template cluster creation, sort of like a YAML template for you, where you can do the tweaking of that, right? So that YAML is what we are going to use to create actual cluster, right? So uh, if you want, you can do this. If not, if you want to like specify your own, that's also possible. So let's see what that looks like, right? So this is going to be our workload cluster. It's going to be of the type cluster. We are going to call it the CAPI cluster API quick start. So this is what I've mentioned as the generic one, right? So this is like there's nothing infrastructure specific here. So you basically want the pod network and those kind of things specified here. And also this holds references to the infrastructure provider and the control plane references. So this could be, right now it's only kubeadm based, but in future it could be something else. And the infrastructure ref. So since we are going to use the AWS infrastructure provider, so AWS specific cluster information will be specified in this section, right? So at first, when you look at this, it might like be kind of overwhelming because it like there's so many lines, but there's nothing much to change here, right? So then if you look at the AWS cluster, so this is like the superclass, and this is like the subclass for the infrastructure. Since we are using AWS, what region to use, and for us to SSH into machines, the SSH key that we are going to use. So this is AWS specific things. So all of your, this is like I'm using a very simple definition. Everything specific to AWS, you have to specify those in the AWS cluster section, right? This is like the generic one. This is the AWS specific one. Then we are going to use the control plane, the kubeadm based control plane. So if we want, like we can give a name to the control plane. So basically this name will be used as like the machine names when we are actually provisioning machines. So that's easy. So this will be sort of like the control plane node names, right? For easy for us to understand. And also in this bootstrapper configuration, right, we are going to specify the extra arguments needed for kubeadm, right? So we all know when we are running kubeadm based installation and we want to use the cloud controller manager implementation for that infrastructure, we have to provide these extra arguments, right? So otherwise, like provisioning load balancers in a particular infrastructure, those kind of things are not going to be done when we say like service type like load balancer. So these are like the kubeadm configurations needed for this to successfully run in AWS, right? So there's nothing much to change here other than the number of nodes. So it follows something similar to the deployment object in Kubernetes, how many nodes we want to run and the Kubernetes version we are going to use, right? So then the machine template, right? So this is again a AWS specific template, right? So you can have like if you're using GCP, you will have a GCP machine template where you can say what is the instance type. So in GCP, it might not be called instance type. It might be called something else, right? And these T3 large or M5 extra large, those kind of things might not exist in that provider. It might be called something else. So basically, this kind of lets you like it separates different things, and you don't have to change a huge lot when you are moving across with different vendors, right? And then we can get into the uh, the the worker nodes, right? That is also going to be a fleet of machines or a machine deployment, just like that, right? So this is going to be our worker nodes. Here also we can say how many replicas we are going to use, what bootstrap reference we are going to use, and what infrastructure reference we are going to use, right? So this is pretty much again like a standard template, and here we can say what kind of machines to use, what like the M5 extra large, those kind of things, right? And the kubeadm config for that as well, right? So right now if you look at it, you might think, oh, it's a huge lot, but actually there's I mean, text wise it's a lot, but uh, uh, what you end up changing is basically, basically the region ssh key and the like the number of replicas and what kind of machines you are supposed to use. So I'm not saying that this is ideal that you have to see all of this, but right now, whether you like it or not, you just see it. But actually, there's nothing much you need to change if you're sort of like uh, using this template to create one, right? So now let's apply this to the cluster. And since this is going to take a while, once this is applied, I'll take some questions as well, right? So right now, if you, I think I showed you this before as well. Right now, there are no clusters. So let's apply this, right? Uh, So what I'm going to do is basically the YAML file I showed, I'm going to apply this to the management cluster, right? So it will start creating this stack, right? So if you look at the cluster state right now, it will say as provisioning, right? And also if you go to the AWS console, there are no instances yet, but this will start spinning up these things. So if you go to things like the elastic IP, yeah, it's appearing. So it's starting to create right now. It doesn't have a load balancer as well, but it will create a load balancer to expose the Kube API server. So those things are going to be provisioned. So till those are spinning up, if there are any questions, I can take few right now.
Yes, my name is Manjula.
Hi,
And is it
Manjula.
possible to, Chamini, is it possible to give the new parameters like Istio enabled in GCP environment, and sometimes it may not be available in AWS. So is it possible to cater for new parameters also?
Yeah, that's a good question. So in here, right? So if I show you the documentation for each infrastructure provider, right? So there are different documentations maintained, right? Uh, so let's say this one. So for AWS, there'll be a separate one. Like all of the parameters for each of the vendors are specified in a different page, Manjula. So like, for example, I'm not very particular about what parameters that you can specify in the GCP, but for example, what in AWS, what VPC you want to use, like whether it should be in a private subnet or a public subnet, those kind of information is available to be provided, and those are going to be provided in these infrastructure specific sections, right? So right now I'm just using like the basic template, but if you read through this infrastructure provider components, it has like like parameters to specify those. So for example, right now I didn't even specify what machine image to use to create the machines. But if you want, let's say your company uses a CSI benchmarked image and you want to use that to create your machines, you can use that. So the answer is yes, but I'm not sure like what specific parameters are there. So for that, you have to refer to the infrastructure providers documentation, Manjula. Hope I answered that.
Okay, but my question is a bit different
Uh-huh.
because if there's a new feature coming in in when you're going through each and every cloud provider, the things are different and parameters are different. So if there is a new feature came in the infrastructure level, in the cluster level, so is it possible to add those features also in spinning up the cluster with this cloud API?
Yeah, you mean like if it's a data kind of thing, right? No special implementation needed, but you want to pass on a parameter to the cloud vendor's API. Yeah, that kind
Yes.
of thing is possible. So basically, like whatever the parameters that you specify here will be passed on. So what is a good one to show here? So if you can specify like extra args kind of thing, and then like whatever's inside will be passed on to that infrastructure provider API. So let's see if I have a, no, I don't have a like extracts specified here, but yeah, that is possible. So basically asking is like, let's say the cloud provider supports adds another different parameter. Do I have to wait till the infrastructure provider does a release for parameter level kind of things? No.
Um, Chamila,
Yeah.
so yeah, so I think this is my opinion here. Um, so looking at the config and cluster API, I believe cluster API is basically spinning up clusters, not managed clusters per se. It's just spinning up VMs and then creating clusters there, right? It's not EKS, GKE, or AKS. It's
Not yet.
just,
Yeah.
yeah, it's doing through KubeADM. So in response to what Manjula is asking, so Manjula is basically asking these, gimmicky features that GKE or EKS or AKS are providing on top of their managed Kubernetes solution. So like you can press tick a button to enable Istio, or you can tick a button to enable gvisor, etc. I mean, you don't really need you don't really need to tick there. I mean, you can install it manually as well once Kubernetes is running, because everything is cloud native and you can easily put those things in.
Mhm.
But yeah, I think that's at the moment the cluster API is currently evolving, and currently it doesn't support managed services. It only supports like allowing through KubeADM. It allows you to set up your own clusters in whatever the cloud environment by spinning up VMs, if I'm not mistaken.
Yeah, that's correct, Nilesh. It's not going to provision like manage Kubernetes clusters. It's basically going to create like the physical infrastructure for be it EC2 instances or compute instances like that, and it's going to use the bootstrapper to turn that to a Kubernetes cluster. So it's not creating GK or AKS or EKS clusters.
Yes. Like to be honest, you don't need to have all of these configurations to have an EKS or a GKE or an AKS cluster. You can just go there, press a couple of buttons and spin one up, or you can just write a simple Terraform script to spin those up. It's this is far more towards managing custom clusters.
Yeah, and this is like the open source version, and like so like since this is they have the VMware backed Tanzu mission control. In that you kind of get the enterprisey kind of features. So
Nice.
let's not talk about it since it's recording.
Hey Chamila, this is Chamil there. With say something related to the same thing, like because they are not the managed clusters. What would be the value this brings? Like for example, like I believe a lot of people, they would not go to set up their own cluster when there is an option for to get the managed cluster in at least these the public cloud. But for example, vSphere, yeah, there will be this will be really good. But what do you think, like in terms of the public clouds with the managed Kubernetes clusters available, where is this value from this cluster API coming in?
Right. Yeah, that's a really good question. So right now, if you are like happy with like the managed offerings cloud provider or like Rancher or someone else is providing, I don't think you need to invest in something like cluster API. But there are a lot of organizations that use sort of like not only in the cloud, they manage like some of their infrastructure on-prem as well. So through SDDC or like a software-driven data center like VMware vSphere, they have some dev and test clusters in not entirely in the cloud. And also there are like the production or clusters like that in a cloud provider. And also another thing is like some of the big organizations have this sort of like cloud vendor locking problems where they have like sort of a exit strategy to be defined and how quickly they can like migrate off of one cluster provider or like a infrastructure provider to something else. So that's why a lot of, I think people are using things like Terraform to sort of like get that infrastructure provisioning abstraction as well. So what Cluster API also tries to address thing like that, where you can like have the same cluster specification or the definition done and execute it against like different on-prem or different vendors as well. So management wise, yeah, obviously the managed providers are like management wise it's gonna like be beneficial, right? But so the like what kind of requirements that your organization has, so this has some feature in that kind of as well. So this is like the free product of Cluster API only talks about provisioning, but then when you go to like multi-cluster management, right? So you have multiple clusters and then you want to sort of like, let's say, apply security policy to all of your clusters, then there's like this multi-cluster management platforms that's coming up. So this, the open source version, you might think it's like only for creating clusters, but if you this is like the first step, and the next step is you have like a centralized thing that manages all of your clusters. So if you want to say, I want to apply this security policy to n number of clusters managed by my organization, you can sort of go there. So this is like, I would say, like the first step towards that. And yeah, I don't disagree with you, like using a managed provider is going to be easy. It definitely is. And if like the networking setup that they offer is okay for your organization, then go for it.
Yeah, and on top of that, the other thing is the bleeding edge features. So these managed services, they always are a couple of versions, 2 or 3 versions behind the latest version. So like if you want the latest stuff, you want to try them out, patch them. And some organizations has these features, and then they have security requirements, right? Like some people want to run Calico only, etc. There are things such as that in enterprises, so where you need the total control. So in scenarios like that, it makes sense. Like especially AWS, what I have seen is EKS is not up to the standards of GKE or AKS. That's my personal view there. So in scenario like that, it's very easy to use some, not particularly Cluster API. There are other things as well, like ranch, etc. But to use something like that, to have spin up your own cluster and sort of get rid of the overhead.
Yeah, there are always some enterprises that don't want to completely move to the cloud. They want to create a cluster on their premises. So I guess in those scenarios, also Chamila, great presentation, by the way. I have like 2 questions.
Yeah, just let me, shall we just like, since this is created, shall we like move ahead with the demo? And
yeah, by all means.
Okay, thanks, man. So, right, so while we were taking some questions, so like the cluster is now sort of created, and if you go to the management console, you will see the machines also created, right? So so this is like the EC2 instances created, and you will have the that's the load balancer. Yeah, the load balancer also created. This is for the API server. So the next step that we need to do is like we need to now we need to deploy the networking solution, right? The CNI plugin, or like the Kubernetes networking, Calico, Weave, or something like that. So in order to do that, right? So we were talking with the management cluster all this time. right? Now we need to actually connect to our workload cluster. So the kube config for that is actually stored as a secret in our management cluster. So what I'm going to do next is take that out and write it to a file, right? So because all this time we were talking about the management cluster and we gave our cluster definition to the management cluster. So right now what we are going to do is we are going to talk to our workload cluster, the actual cluster that we created, right? So let's apply the default one, that is Calico. And now if you see nodes, so right now it should show as not ready because the networking is not deployed. Yeah, maybe before I get to that, this might start running as well. Who knows? Let's see. So now I'm actually connecting to the my workload cluster, not to the management cluster, meaning the cluster that we created in AWS. So these are right now not ready because the networking solution was not deployed. Yeah, so those are getting ready one by one. Right, so that is ready, and so that's about it. Just to show that like this is actually the infrastructure that we created actually works like a cluster in AWS. Let's try to deploy a sample application. So we don't really care about what's in the deployment, but if you try to provision a load balancer, this should actually provision a load balancer in AWS if the bootstrapping happened correctly. Basically, we want to make sure that these args were used correctly, and indeed a cloud controller manager for AWS is running here, right? So so if all goes well, we should start seeing another load balancer here. Yeah, so it's coming up, and we have the machines created, right? So so at least for AWS, I mean, so if you like Nilesh also said, right? So some organizations have very strict guidelines of how you want to provision your infrastructure, right? How your AWS machines are going to be provisioned, how the subnets are going to be created, and then the red zone, orange zone, and the green zone, like how the subnets are defined, and where you want to deploy the Kubernetes cluster and we are going to have the load balancer like that. So those kind of configurations also, let's say in here, what we did is we didn't specify anything about the infrastructure. The actually cluster API created the instances, even the security groups, the VPCs, everything for us. But if we want to use, like, we want to provision our own infrastructure through Terraform or something like that, and then use it with the cluster API and use cluster API only for Kubernetes cluster provisioning. That means like the cluster machines and the VPCs and everything is provisioned by us. That kind of functionality is also there, but so don't use this in production yet because it's V1 Alpha 3, and it's kind of ongoing development, right? So for you can check the differences between these two, like the previous version and this in the docs, and there are some kind of big steps happening as well. So yeah, that's about it for the presentation. Yeah, if there are any questions, I think we'll be able to answer now. I think we're kind of over time as well, but
I think Binra had one.
Oh yeah. Yeah. So the first question was, this operator, does it do anything other than wrap KubeADM, as in terms of upgrades or uh, I don't know, anything related to management of the cluster, just keeping it healthy?
Yeah, it actually does. So the one controller, actually only one controller is managing this kubeadm based thing, that is the bootstrapper controller. So right now it's kubeadm, but in someday there'll be other bootstrappers as well. So for example, if I let's say I go to these instances, right? So this is like built on top of a Kubernetes cluster. So if I just delete something like this, so it will actually recreate that. So the management cluster will detect that, and it will actually keep the cluster in sync, right? So
All right, that is interesting. So if like a node gets, I don't know how a node would get deleted, but if it did, it would be recreated.
yeah, basically because we gave the number of replicas through the machine deployment,
Yeah,
it actually
that's
evaluates
what
the cluster as
Kubernetes
current
does. Yeah,
state. Yeah, exactly. It basically
yeah,
is Kubernetes controller loop running in
that is
their
interesting.
CI. Yeah.
That's good.
So in a scenario where like a node would fail or something like that, would that still kick in, or is that outside the scope of the cluster
Uh,
API?
in the sense like what we did right now, right? So I'm
Yeah.
not sharing my screen. I just actually deleted one of the nodes, like the EC2 instances. So
Oh, okay.
cluster API will. So sorry, I wasn't sharing. So
No, no.
it's actually going to create one. So there's like a time that it detects a node eviction time. So after that, it will actually create this one.
So even if a node becomes unhealthy, say uh, there's some failure on the side of the cloud provider, would it still create a new node? Like it's not a complete disconnection, but uh,
Mm, I'm
maybe
not
I'm
sure
getting
about
too bogged
the
down in the
exact
specifics.
logic.
Hypothetical, let's say you just SSH into one of those machines and then manually stop the kubelet service running.
Yeah,
Mm.
that would be a good example. My second question was, I'm not sure if you looked at um, the side of things, but is it possible to sort of create clusters with hybrid configurations like nodes, some nodes on GCP and some other nodes on AWS and sort of map the VPC? So is that possible to do with the cluster API, or does it still require that manual?
VPC configurations, yes, it can say put these nodes in this VPC and even in this subnet, yes. But same cluster, some nodes on AWS, some in GCP, you can't do because for the infrastructure provider, there's one template that you can use for
Yeah.
a single cluster.
Yeah, yeah, that makes sense. Cool, cool. Thanks, Chamila. Great
Yeah,
presentation, by the way.
thanks, man.
Thanks.
Okay.
Anyone else have any questions?
This is Shamid again. I have another question in terms of now, for example, I wouldn't believe the management cluster requires a HA. Probably it might not require, but then again, let's say if we do lose the management cluster, and what would be the best place? Like, should we keep a HCD cluster HCD DB backup, or should we get the manifest and start up again a new cluster and get the manifest and reapply? If we do that, will it create another cluster, or will it maintain the same cluster?
It will maintain the same. So if you back up the cluster state, right? If let's say you use Valerio or something like that to back up the cluster state, and so it won't actually create a new one. So basically, as long as those manifests stays true, it will try to connect to the cloud provider, and it will try to reconcile the state again. So it won't actually create new ones, Chaminda. So
Right. So in this case, even the other part comes then the management cluster upgrades. So we sort of can keep a backup and then destroy the management cluster and create the management cluster with a new version, and then and restore the database So is the other thing like, is a chicken and egg situation, like you need a Kubernetes cluster, then this management cluster needs upgrades and maintenance of it. So,
Yeah.
How are we going to do that?
Yeah, so there's a thing called pivoting, which we didn't get into right now because, frankly, I think we like each of the versions, like how you do that, it's kind of like changing, right? So in V1 Alpha 2, they had this concept called pivoting. So pivoting is like you create like a kind or a mini cube or a managed cluster, and you use that as the management cluster, and then you use that management cluster to provision your workload cluster, which is like a highly available cluster with multiple control plane nodes and all of that. And then you can use that pivoting. So what pivoting does is it takes the custom CRTs of the management cluster, and you can put that into that high available cluster that you just created. So you can basically take the CRTs that you created and like basically apply the cluster API resources to the workload cluster, which is a highly available cluster. So it's like you are creating like self-managing Kubernetes cluster in that sense. So that's one way called pivoting that can be done. Or like, so really like ultimately, if you want, right, so you could have a managed cluster created for the management cluster as well. But pivoting is another option. So basically take the whatever the custom resources that you had in your management cluster and move that to a highly available cluster, meaning again a workload cluster.
All right, thanks, Chamila. It's really good one. Thank you.
Okay. Anyone else have any other questions? I have one last question, Chamila. So if you edit these configurations and reapply, behind the scenes, the infrastructure and everything is going to get updated, yeah?
Yeah, so for simple things like, let's say you increase the replicas to 5 like that, like the controller detects that you need to create one more node and test that. But I haven't like actually tried, let's say like you take the Kubernetes version upgrade or like change the version, and let's say we do that only in the control plane node, what happens. But for simple things like change the machine instance type or like change the number of replicas, it actually does that upgrade. So basically it takes down a node and creates a new node with the new instance type. Things like that is out of the box supported, Nilesh.
Oh, excellent. Yeah, that's what I was wondering, because the main thing is the certificate rotation, and sometimes you need to add API SANs, so stuff like that, and then version upgrades too. Did someone else have a question? I saw somebody unmuting the mic.
Oh, just me. I kind of have read the little bit of a documentation while the presentation going on to check the upgrades, and it says it supports the upgrades, and it does the rolling upgrade as well for the both control plane as well as the worker nodes as well. So looks, I believe they said like it's just a way of changing the version. So it looks it does support upgrades the versions of Kubernetes.
Excellent.
Okay, cool.
It's interesting.
Yeah, and finally, like Rancher does the same thing. So Rancher has this thing called RKE. So backing up the etcd cluster, is that something you can do with the kubectl command using the cluster API with one of their resources, where you can sort of set up a schedule where you can push the etcd back up to an S3 bucket or somewhere in the particular cloud provider, and have regular backups? Is that something we can configure with the cluster API?
Not that I know of, Nilesh. I'm not sure whether I'm like not confident to say no, but I haven't like seen anything like that in the documentation.
Oh, okay. All right. Okay. Uh, right. Anyone else have any questions? Mm, so shall we wrap up then? If nobody somebody has asked a question, is it possible to configure security groups, routes, and DNS along with cluster API? Well, no, isn't it? I mean, that's kubectl specific. So once you set up the cluster, then you can sort of set up these security groups, configurations, etc. I mean, Shamila, your thoughts?
Yeah, so if it's like anything related to the Kubernetes cluster itself, you cannot actually do. But if you're talking about like the infrastructure level security groups, like the what security group use in for VPCs and like the inbound connections, things like that, those are possible. But no, I mean, like if it's something related to the Kubernetes cluster itself, like the network policies or things like that, then you cannot do it through cluster API.
Sure. So I just want to check the so when we bring up the cluster API, so it bring up with the one some virtual machines, right? So it is possible to the virtual machines which is belong to that cluster to add a DNS record in the route 53 and the security groups which is belong to the minions, those kind of stuff. So I think it is possible, right?
Yeah, so you can what you can do is like if you have a pre-provisioned VPC and you have subnets and those kind of things, you can tell cluster API to, instead of provisioning your own stuff, use this stuff.
Okay.
But like let's say like run a user data script, something like that. So you'll have to like have either have that sort of like in the AMI that you are doing, and then use cloud init or something like to initialize that. So but like if the infrastructure is there, use this infrastructure and use this configuration, you can tell. But I don't know like the exact thing that you said, like to put a node, like a host entry or something like that to the node, kind of a command is there. But yeah, basically you can use the existing infrastructure that you have provisioned. Let's say you are going to use Terraform or something like that to provision the infrastructure and provision my nodes in this boundary, that kind of thing you can specify,
Okay.
at least in AWS. Yeah.
Okay. Thanks.
Okay. Anyone else with any other questions? Okay. Yeah, go ahead.
Oh, just one quick question. Do we have any idea of when this will hit GA?
Soon, right? So last time the in around October, no, maybe a little bit earlier than October, they had the V1 Alpha 2 release, and then
Uh-huh.
V1 Alpha 3 was done in April this year. So
Oh, okay.
it's not
It's going
really
slowly,
fast
yeah.
as well. So like I kind of think like that's why they have this tortoise in their logo. It's
Oh,
kind of
to slow
yeah.
how,
So
I see. So might take a year or two, yeah.
I mean, there's a
yeah.
chance they might completely shut it down. Also, there was another one where the multi-cluster application thing, they shut it down. I remember, where you can deploy to multiple clusters at once.
The Federation one.
Yeah, yeah, yeah.
Federation.
Oh, the Federation API, yeah, that never made it. But there's still a Federation API
Yes.
around, yeah?
A new version they were working on from the ground up or
Hmm.
something.
Oh, okay. Interesting, interesting.
But
And
hopefully, I think this can go on to this will become better with the backing of a few enterprises that are currently as mentioned earlier.
Mhm.
So I believe maybe next year again we might have a good there would be more features. I think the problem is Kubernetes is also releasing at a faster pace new
Yeah,
release
they are.
features and new
Yeah,
configurations.
it's almost impossible to keep up with them. This point. Yeah. All right.
Okay, anyone else have any questions? Okay, then shall we wrap it up for today? If everyone else is okay. Right. So thank you, Chamila, for taking your time to deliver us this presentation. It was really good. We really enjoyed it. And thank you all of you who joined us and asked questions and made things interesting. And we would be doing more of this in the coming future. So the next webinar we would be doing is we are going to talk about DNS and cybersecurity uh, with related to Kubernetes. And yes, so we will be posting about that soon in our webpage on the Facebook page. And we will post this recorded one also on our YouTube channel, so that if anyone wants to refer or have a look at, you will get it. And then Chamila will provide us with the uh, all the YAMLs that he showed, and that we already put the link to the presentation. So everything we will share. Okay. All right. um right, so since nobody has any other questions, yeah, Chamila, you have anything to say?
No, so thanks for having me here, Nilesh, and it's a really good thing that you guys are doing, helping out the community with these kind of meetups. Glad I could be a help. Thanks.
Thank you. And then also, guys, go have a look at Shamila's YouTube channel. KubePSL had great Kubernetes content. Like if you are starting on Kubernetes, or like if you are university students, etc. He explains. I mean, if you look at today's session, also he explains everything from zero to uh, the advanced features. So he has done a great job there. So go check the channel out too. Okay, thank you all, and we'll see you next week.